So geometric sequences review for the homework here. We're going to discuss number 3, number 4, and we'll finish the problems we didn't get to in class. So the first idea is always to determine if the sequence is geometric. Okay, so we should understand that in a geometric sequence we need to have a common ratio. Okay, and that common ratio is going to be discovered a couple different ways. I hope you guys have the instincts to be able to look at this and see, okay, 3 times, negative 3 times positive 3 makes negative 9, and negative 9 times positive 3 makes negative 27, and negative 27 times positive 3 makes negative 81. Okay, so this value is our common ratio. So our common ratio is 3. Another way to get this, okay, another way to get the common ratio while we're talking about it. One way to get the common ratio is to take any term of your sequence, so we could start with this one, and then divide it by the preceding term. So the preceding term to negative 81 is negative 27, right? So negative 81 divided by negative 27 will give us positive 3. Okay, so again, the common ratio implies that it would be the same thing if I used any numbers, right? So if I took negative 27, I just have to divide that by the preceding term again, right? So what's before negative 27 was negative 9. So if I divide that one by the one that comes before it, I get 3 again. So notice that this number was 3, and it's 3 again. And if I take 9 and divide that, negative 9, by negative 3, then that'll give me another one, right? If I look at negative 9 by negative 3, that also gives me 3. Okay, and so we end up saying, hey, there it is. We have 3 different values. Sorry, 3 different ways to calculate the same value. Okay, so we see that that's how you find the common ratio. So every now and then you'll probably be able to get it just by looking at it. So I can't help but mention all of that while we're doing this problem. So now that we know that there's a common ratio, that tells me that this is a geometric sequence. So we could say, yes, it is geometric. All right, it is a geometric sequence. So this is a geometric sequence, right? So now we move on because it says if it is, and it is, then we got to find the common ratio. Okay, but we found the common ratio. The common ratio is 3. So now we can move on. It tells us to find the 8th term, okay? But we got to hit the brakes a little bit. We can't get the 8th term until we find a formula that could get that. Otherwise, we're going to just be multiplying by 3 lots of times. And that's not necessarily a foolproof way to do this, because every time you do an operation, you got a chance of making an error. So we're probably better off doing another procedure to figure out what that is, rather than just continuing the list one at a time, all right? Especially imagine that this said the 80th term instead of the 8th, right? We wouldn't want to do it that way because that's going to be way too much work, right? So let's start off by getting the recursive formula. I've been writing the recursive formula in red, so we'll do that right now, okay? The recursive formula of a geometric sequence has this form, okay? It's where you take the function, okay? And again, I guess I can say that this is the geometric recursive formula. So we take the nth value, okay, to get the nth value we have to take the n minus 1th, and then we're going to multiply that by our common ratio. Okay, so that's all this is telling us. It's saying, hey, to get the next one, you want to take the one that came before it and multiply it by the common ratio. I mean, and look at what happened. How did we get 81? Well, we took the one that came before it and we multiplied it by the common ratio to get that. So that's really all this equation means. That's what it's explaining to us. That's the information it contains. So now to finish this up, when we're going to break this down, we want to get our specific formula for this sequence. So to get the specific formula, we only have to substitute in the value of r. Okay, and our common ratio in this case was 3. And so I'm going to put times 3. Okay, so this is our recursive formula. That'll work for now. Now to get the explicit formula, all right? I'm going to clean this up and erase that, and then we'll write the explicit formula in this spot also. So the explicit formula again, this one is for geometric series. So this is the explicit formula for a geometric, all right? That changes everything. If this word was arithmetic, then we have to use a different general formula, all right? So the geometric explicit formula is f of n equals f of 0, our first term, and then times r to the n. Okay, now we said we would do this when we start counting at 0. And I emphasized that today because we knew sometimes we'll have to start counting at 0. So today we just kind of started. And pretty soon you guys are going to have to start making your choice at which way you want to start counting. Do we start counting at 0 or 1? So today we started counting at 0. And so we'll consider this first entry in our sequence, this first term, we'll call that f of 0. Okay? So that's that value. Okay, so when I go write the specific formula, again, right, the one that I wrote in red right here, this is the general formula. This works for any sequence. But what you have to change is these two values, right? I have to change this f of 0. I have to change that into the specific value for this sequence. In this case, today we see that it's -3. So that's what I put right there. Okay, now to get the common ratio. The common ratio happens to be 3. So we put 3 right here, and then we have an n that goes right there. I've been trying to show people that at this step, when we have an n there and an n there, that should continue. When I have an n here, we still have an n as the exponent. So far, that's the explicit formula for this sequence. So now, we got almost everything we need. The last part that we have to do is actually get the 8th term. So as we said today, since this sequence is considering f of 0 to be the first term, that means that if I want to find the 8th term, I have to calculate f of 7. So to calculate f of 7, that means I'm just going to switch n into 7. So notice the only thing that changed, right? This was an n and that was an n, and now it's a 7 and a 7. Okay, so I'm trying to get you guys to see that again. These n's match, and so that 7 and that 7 has to match right there. So now to finish up this calculation, we have to do -3 times 3 to the 7th. And so evaluate that. Probably wouldn't do this by hand. It's possible. But once you get up to pretty big numbers, we want to check and make sure that we're right. And so it's pretty useful to have a calculator there. Now, 3 to the 7th is 2187, right? So now we're going to multiply that value by -3. Okay, and if we do that, we should get -6,651. Sorry, 561. Yeah. 6,561. There we go. So this value is the end of the problem, right? We finally got the 8th term. Okay, so I know there's a lot to do here, but just keep track of it. Okay, we're trying to organize all of our information all at once. The recursive, the explicit, and the 8th term, the common ratio, and basically the definition of geometric sequence are all contained in these one problems. All right, so you got to get a rhythm. Once you establish a rhythm, I think the problems will get easier. So we just did number 3. Let's go move on to number 4. Okay. Let's start going a little faster. So on this problem, we can see that our common ratio is 4. They're all getting multiplied by 4. That's getting multiplied by 4. Okay, so R equals 4. Okay, and then this first term is f of 0, okay? So we will get the recursive formula, okay? And also we know that because the common ratio is equal, this is geometric. So I almost left that out. Okay, Okay, the reason I didn't leave it out is because I went back and read the problem and I saw, hey, it says this to do it first. So I knew that that's the first thing I should think about. Okay, so it says find the common ratio. And we got the common ratio. The common ratio is right here. It's r equals 4. Okay, we want to get the 8th term. We know what the first term is. Again, the first term right here is our f of 0. And that's negative 1. Okay, so we can write some of these information pieces up here. We got f of 0 equals negative 1. Okay, and then again we know that r equals 4. So there's our common ratio. Okay, so the recursive formula. To get the recursive formula, we know that the next term is equal to the one before it times our common ratio, which is 4. So this would be it for number 4. Now to get the explicit formula, what we should have is f of n equals f of 0 times r to the n. Okay, so now we're just going to substitute in the values that we have this time. Okay, f of 0 is negative 1. And then we have to multiply that times r, which is 4. And then we're going to bring that to the power of n. Okay, so there is our explicit formula. So we have our recursive formula, our explicit formula. Now we just have to get the 8th term. Okay, and what are we going to do to get to 8th term? Okay, so this is our explicit formula, and I want to find the 8th term. Again, why am I plugging in 7 instead of 8? Well, that's because we started counting at 0, and I'm trying to teach you guys that that's something that happens every now and then. So you just got to learn how to deal with it, and then eventually you guys will have to pick and choose the situations when we do that. So f of 7 right here, we got negative 1, and we have 4 to the n, but since n is 7, we'll take 4 to the 7th. So I have negative 1, and then we have to do 4 to the 7th in the calculator, so calculate that correctly. We do 4 to the power of 7, and I get 16,384. Okay, because I'm going to multiply that by a negative, it's just going to turn to negative 16,384, right? You multiply something by negative 1, it just changes the sign. So this is the answer for number 4 right here. Okay, that one went a little faster, so I try to do it quicker. So now we'll move on to 5 and 6. All right, number 5, the whole point was that this is not geometric. Number 6, this is not geometric, but I wanted you to actually show me on the paper 2 numbers that were not the same. Okay, so I want you to show me, what do I have to multiply 10 by to get 12? Okay, well, it's not going to be the same number that I have to multiply 12 by to get 15. So you want to write something down. Okay, we'll go do number 7 right now. And then for number 8, I'll project the answer so that this video doesn't go too over. And I think I did 8 in a couple of my classes anyway, so this should be enough for you guys. All right. 2 times 4 gives me 8. So right now I want to check 4 immediately, right? Does 4 work? Hey, 4 times 8 is 32. All right, does 4 times 32 equal to 128? And it is. So that's true. So not only do we have a common ratio, but we know this is a geometric sequence now, right? So we got that first one done. Yes, it is geometric. Okay, so that part is done. Okay, it tells us to find the common ratio. So we know our common ratio is equal to 4. And then we know our f of 0, right? Our first term is 2, right? Just look at the sequence right there. So now let's get the recursive formula, the explicit formula, and then we'll have this one complete. All right, on that last problem, notice that I didn't write the whole formula. Okay? I didn't want to waste the time in between the steps, right? I was trying to make the video go faster. So what I would have written was the part that I just wrote in black. And now underneath, for this next step, I've been trying to get you guys to see that when I substitute in the common ratio for this problem, right, that's when I get the explicit formula for the one I'm trying to get. Understand? So the answer is what I just put in the blue box. That's the recursive formula for this sequence right here. You understand? This one takes me to this little list of numbers over here. So now we need to get the explicit formula. And the explicit formula is down here. F of n equals f of 0. Okay, so f of 0 again is the first term in our sequence. What's the first term in the sequence? 2. So what do we put right here? We put 2. Now it's going to be times r to the n. So the r that we have to put down is our common ratio, which is 4. So we put 4 right there. Okay, we could put parentheses around here too. Either way, it's not that important, but just understand that we have to multiply before, sorry, this is the exponent before we multiply. So I put an n right here for our exponent again. Okay, so notice all we changed was the value for r, right, and the value for f of 2, but we didn't change the n. Notice there was an n here and an n there, there's an n here and still an n in those two places. So try to focus on that when you're confused about the way to use this notation. Okay, the next thing that we're going to do is find our 8th term. So that will be finding f of 7. So we can maybe just calculate that over here on the side. So if I want to calculate f of 7, okay, then that means I'm going to do 2 times 4 to the 7th. Okay, so again, that just means 2. And then I have to actually calculate 4 to the 7th. So that calculation gives me 16,384. Okay, and if I do that times 2, and I get this value, that is 32,768. Okay, so this is f of 7. Okay, so this is the end of number 7. I'll put the answers for number 8 at least on the board so you guys have something. All right, if you got any specific questions, write it down. Or if you can't wait, if you got a really good question, feel free to send me an email or something, right? I'll put the answers up here. And there we go, okay? Just understand that the formula is going to look a little different here, but the main thing you guys should focus on is getting the right answer for the 8th term. If you got that, you probably did everything else correctly. Good luck.